Hi, this is Bob from INSYDIUM, and in this video series we'll look at recreating this particle Christmas tree. Now this is actually 3 simulations combined, so in this first video we'll look at our first technique using xpFlowField and some modifiers to get this fantastic particle movement up our helix splines. We'll then take those particles and we'll get them set up to render in Cycles 4D. Let's set up our first particle simulation then. So we'll go to the INSYDIUM tab, let's bring in an xParticles system, and this is our organizational hierarchy. By default we get an xp emitter brought into the scene. Here it is here, and there we have our particles. So what we're going to do in this simulation setup is we're going to use these splines. We have 3 helix splines in our scene. We've got an outer, we've got a mid, and we've got an inner, so they're all separate helixes, and what we're going to do is emit from these, and then we're going to get the particles to kind of move along in the general direction of them going towards the top of that tree. So let's get the emission of those particles sorted first. So we'll go to our xp emitter. We want to change the emission type from the default square emitter. We want to emit from these splines. So let's go to the object tab. We'll go to the emitter shape, change it from rectangle to object. And then it's saying what object do you want to emit from. So what we can do, look, we can just drag in this helix splines null that's containing all of our splines. Let's just drag that in there. Let's change the emit from polygon center to, what do we want, edges. And now if we hit play, those particles are emitting from those splines. Let's just change the display of those. We'll go to our emitter, we'll go to our display options, and we'll change the editor display from squares to dots. There we go, there's our particles, and let's just increase this number by a lot. It's 1000 per second we're emitting at the moment. This is in the emission tab under the birth rate. Let's change that to 20,000, and then we're going to have loads more. Very good. And we don't need them to be living for, at the moment, they're living for the entire length of our time of our scene, which is 1000 frames, and obviously we don't need that. So we'll click off full lifespan, and we'll change it to, we might adjust this, but we'll just put it at, say, 80 frames, and then we'll put a bit of variation, so not every particle is dying off at exactly the same time. Okay, so as you can see, our particles are just flying off, and that obviously isn't the look that we're going for. We want them to kind of flow along our splines. So the way we're going to do that is with a dynamic object called a flow field. So let's go to our dynamics, and then we can choose a dynamic object, and we're looking for a flow field. There we go, xpFlowField. And when we bring that into our scene, we get this bounding box, and we can see these squiggly lines inside. So what the flow field does, it creates a custom velocity field inside of this box, and the velocities within that will affect our particles. So what we want to do is make sure that our splines are fully encased within this box. So let's use these handles to make it taller, wider, and deeper. Now you can see that we're displaying the default velocity field that FlowField is creating, this random velocity field. And these trail displays here are just showing you those velocities. So if we hit play now, you're going to see that instead of those particles just being pushed outwards, now they're being affected in these swirly ways, and we can see the effects of that. Now the reason we're only seeing kind of one flat plane of these velocities, it's just a display type. These are being created within the entire volume of our bounds. So if we go to our flow field display tab, and look, the mode is set to the XY plane, so we're seeing these velocity trails on the XY plane. If we change that to voxels, we'll see the entire grid full of those random velocities that our particles are inheriting. So what we could do is, look, let's just change that once more to XY plane, and we'll change it from these trail displays. Instead of displaying that, we'll have a look at arrows. And now we can see that all of these different directions is what is moving our particles around. So let's have a look at adjusting this, because we don't want this random configuration. We want these velocities to be pointing in the direction of our splines. So let's go to the FlowField Object tab, and here is our default random layer, which is creating these random velocities, and we want to just get rid of that, so let's just delete it. And now we haven't got any in our flow field, and we're just back to square one. So we want to reference these splines to create some velocity vectors. So let's go to our add layer list, and we want an along spline. Okay, but this obviously needs a spline to be able to reference. It doesn't know what to look at yet. So let's just move our object manager down until we can see our helixes. So we'll pick in our objects list, we'll get the picker, and we'll click on the helix inner, mid and outer. Okay, and now that we've done that, look, you can see that our arrows are now pointing in the direction of our splines, and they're changing color. Look, they're green nearer the spline, and then they're changing color to blue, and this is because we have by default a fall off activated. So really close to the reference spline, we've got full strength velocities, and that strength tails off until it's blue, and then there's no strength at all. So what we need to do is just get rid of that. We don't need any fall off at all here. We want everywhere within our bounding box to be affected the same. So the way we do that is just move down in our flow field in the object tab, and look, by default we have a fall off with a spline selected, and we could make adjustments to this. Look, if we increase the distance, we'll get strength moving away from those splines, so that we've made a much bigger fall off area there, or you can make it a really tight fall off, or we can just get rid of the fall off completely. If we click that off, now we have just got full strength velocities throughout that entire domain. All right, so now we've got that, we don't need to look at these anymore. Let's go to the display and let's just switch off show vectors. We don't need to see any of that information. And if we hit play though, you're going to see that our particles are starting to move around in the direction of those splines, and look, they're making their way up to the top. So we're getting closer to what we want. Let's go back to the object tab. We could increase the strength of this. Now, if we increase the strength of our flow field, the particles are not going to be able to push outwards as much with their initial speed that they're getting from the emitter. Look, let's pull this up and you'll see, look, they're getting much tighter to our splines. So that's kind of what we want. That's looking good. So what we could also do here now is we can let's leave our flow field alone, but let's try and add some more movement to this sim. So we're going to do that with some xParticles modifiers. So we'll go to our modifiers tab, and first of all, let's bring in a turbulence to add some swirly turbulence to this. So let's add a motion modifier, xpTurbulence, and we're seeing a little bit of turbulent movement here, so we're having an effect on our particles. Let's increase the strength of that way up to maybe 20, so a very strong turbulence. Okay, and then let's reduce the scale of it, so it's a smaller curls that we're getting. So this is looking quite swooshy and quite nice, but it's getting a bit out of control. It's getting faster and faster, and it's moving far too quick. We need to calm this down. So we can calm it down by, we want the same strength of the forces, we want the strength of turbulence, and we want the strength of the flow field, but we want to limit how fast the particles can move. We don't want to change their movement, we want to just limit how quickly they're going to move. So to do that, what we can do is bring in a speed modifier. So we'll go to our motion mods again. Let's bring in an XP speed. Now by default, this is set to incremental speed. So they're just going to get faster and faster and faster. So this is almost the opposite of what we want. But here's a really cool trick with it. If we put the speed value, so it's going to increase speed 150 centimeters. If we put this to 0, there's going to be no difference in speed at all. So we've almost effectively switched the speed modifier off. But what we're able to do is have no increase in speed, but we can clamp the max speed. So look, let's click on clamp max speed, and let's clamp that maximum speed way down to something like 80 centimeters per second. And now if we hit play, we're getting that same directional change with our turbulence and with our flow field, but look, we've clamped that speed way down, and we've pretty much got the look that we want for this part of our Christmas tree. This is looking fantastic already. The only thing we need to do is sort out this top bit, because they're a bit out of control and we need them to kind of almost come into a point here. So the way we can do that is with another modifier. Let's go to the modifiers list. We'll go to the motion modifiers. Let's bring in an attractor, which brings in this target here. And if we hit play, the particles are going to be forced towards the center of this target. So here we've got forces fighting against each other. We've got a flow field trying to get them to go up. We've got the attractor trying to get them to go down. And we've got the turbulence trying to get them to go all over the place. So this is kind of not right yet, but we've got the tools here to sort this out. So let's move our attractor target to the point above the tree. So that's cool. But this is attracting all particles in the scene at the same time. We don't really want to attract these lower down particles here. So what we're going to do is limit the effects of this attractor with a field. So let's go to our attractor, fields. We'll add a spherical field. Here's our spherical field. And what this is saying is, let's just make it a bit bigger. What it's saying is, if a particle is here outside of the sphere, it will have no attraction force. As it comes into here, it will start to get attraction force. And as it enters the inner field, this sphere here, it'll have the full attraction force. So now if we hit play, you'll see that, yes, look, these lower particles are not being attracted, but the upper ones are. Okay. So let's just sort out, make a couple more changes. What we're going to do is put our attractor after our speed and turbulence. And what we will do with our attractor, let's go to the Object tab. And instead of this being a velocity type attractor, we want this to work with the other velocities working in this scene, both the flow field and the turbulence. So let's turn this into a force instead, and this will better enable us to mix the effects of this with the effects of the flow field and the turbulence and the other modifiers. So if we hit play, now we've got this force. Now what we want to do with this force is increase it so they're really going to kind of come into a point. See, we've increased that, and now this is coming into a thinner point, but they're traveling a little bit too quickly. They're suddenly accelerating, and we don't want that. So let's put a speed limit here as well of something like 70. And there we go. So that's working a lot better. We could even reduce that acceleration down a bit as well to say 150. There we go. So that is looking excellent now. And very quickly, we've got a result that is looking pretty good in our scene. So what we're able to do at this point is let's just keep this as is for now, and we'll start setting up rendering this part of our Christmas tree. And then if we need to make further adjustments to the actual simulation itself, that's something that we'll be able to do. So now let's just dolly out in our scene, and you'll see that we've already got two Cycles 4D lights set up here. We've got this blue softbox, one behind, and we've got an orange softbox in front. So that's what we're going to use to light our particles. And you can see in our scene that we've got this light's null. If we open this up, there are our two softboxes. We've also got a null in there called Snow Chunks Geo, and we're going to use those a little bit later to make our particles look a little bit better in the render, but we'll look at those in a moment. Before we do, if we just play through a few frames to get some particles in the scene, you're going to see that, let's just stop those there. If we go to our INSYDIUM Cycles 4D real-time preview and try and render this frame, we're not going to get anything. Look, it's black, and that's because we've got no material on these particles. So let's get that sorted. We'll go to our material manager here, and we want to make a new Cycles 4D material. So let's click on this little arrow. We'll go to Cycles 4D surface, and we're going to use a translucent BSDF material. Let's do that. we'll drag this onto our emitter. And straight away, look, actually, we're getting something. Now, let's just make a couple of adjustments before we have a look at exactly what's rendering here. Our translucent material is really simple, but very effective. So if we double click this, we'll get our node editor. And every material in the node editor will contain an output node. So this is kind of the object effectively. And here is our translucent shader. It's just one node, and the output of the translucent is being fed into the surface of our object, the surface of the object that the tag's on. So that's cool. All we're going to do is change this default color, which is a kind of an off-white, to white. Close that down. And now we have got this material. So what we could do is, let's just close down that material manager, move that over there. We'll just dolly in a bit. And if we come in really close to these particles, you can see that for every particle that's been created by the emitter, Cycles has instanced automatically a sphere. Now that isn't what we want, but it's quite useful as a default. If we move that over again. So we've got no control over this sphere at the moment. If we wanted these particles bigger, we'd have to re-simulate to make them bigger and make any other changes. But what we can do is make render time changes to particles using an instance tag. So let's do that. We'll go to our emitter, go to tags, extensions, INSYDIUM, cycles, and then let's bring in an instance tag. Here it is. So everything looks exactly the same. But now this instance tag, let's have a look at the settings, are controlling the spheres that are being generated, which is the default object. So look, we don't need spheres to have 24 segments. That's creating a lot of geometry that's not going to be necessary at this scale. So we could first of all reduce this down, which is going to speed up render times. Now those spheres aren't going to be as perfect a sphere as they were. You can see they're a bit more jaggedy. That's because they've got fewer segments. But actually for us that's fine. But now look, this is the really cool thing about it. We can now increase the size of those spheres should we wish with this size multiplier. And now we're getting bigger spheres. We can add size variation. Let's add 100% variation and then reduce that size down. And you'll see that, look, we've got small spheres and bigger spheres. And if we increase that size variation even more, look, we've got some tiny spheres and some really big ones. And this is all just happening at render time. We're not having to change our simulation at all, which is fantastic. Let's put that variation back down to 100. So that is that. Let's just close down our real-time preview. But what we're going to do to make this more realistic is that instead of just rendering these default spheres, we're going to instance some custom geometry. So if we go down back into our lights folder here, we have this snow chunks geo. And if I open this up, what we have in here is 10 XP join objects. And inside each one, we have a sphere, Cinema 4D sphere, which is being deformed by a displacer. So if I make all of these visible, and let's move down, these are at the bottom of our scene. If I dolly in, this is what all of our custom objects are. Let's hit ND to see the lines. So we've just got 10 deformed spheres that are like these little rocky chunk things. Okay? And what we can say to Cycles is, for every particle in the scene, choose one of these objects randomly and render that instead of the particles themselves. Okay, so what we need to do is, let's go to our instance tag, and then let's open up our snow geometry. And what we need to do, we need to make sure that each one of these objects has our translucent material on. So let's just select our translucent tag here. I'm going to hold Control, drag it and copy it onto this top parent null. And then on this, I can just right click and we can copy tag to children. So now all of those joins have got it. So now let's go to our instance tag, and in our objects, this is where we need to put all of our join objects, all of our geometry. So we'll just click on the eyedropper, and then let's just pick all of those. So they're all going to go in that window. Great, they're all there. So now if we come back out again, dolly right back out. So now if we go to render this, let's go to INSYDIUM, Cycles, Real-Time Preview, and let's get this rendering. Now instead of those all being spheres, we have just rendered loads of instances of our snow geometry. Okay, excellent. So let's go back into our instance tag. What adjustments can we make to this? Well, first of all, we can add, at the moment, they're all just being instance and they don't have any rotation. So what we could do is, let's add 360 degrees rotational offset on all of the axes. So that effectively has made no difference. It's just spun them all around 360. But now if we put 100% rotation on those, now they all have random rotation values. We can reduce the size. They're too big. Let's bring this way down. They're still too big at 20. Let's put them at maybe 5% to make them small. But let's increase the variation. And we could possibly go a little bit bigger than that. Okay, so something like that looks pretty good. So let's dolly out again. So there we go. There are our snow particles. And depending on what look we're going for, we can make adjustments to those. But let's just leave it at that for now. All right, so that's looking really good. We've set up the render of our snow-based particles. So now let's just get rid of that. So now what we need to do is add some of the other elements, and these are going to be some of those Christmas light particles. And the way we'll do that is we're just going to make another emitter. So let's just get this emitter, and let's call this one emitter, and then we'll call it snow. And then let's duplicate it. So hold Control, drag it down, and this one will rename as emitter lights. And the emitter lights, we don't want as many. We'll just switch the snow off for now. So the emitter lights, we don't want as many lights as we've got snow, obviously. So let's go into the emission tab of that new emitter and put this down to maybe, let's just try 100 for now. And if we hit play, so we've got far fewer particles, but these are lights, so we don't need as many lights. So that's looking possibly all right as far as lights go. So now what we're going to do is we can leave everything the same, but let's go to our emitter lights instance tag. And actually, these are lights, so these can just be spheres. That's not a problem. We don't need all of these join objects in here. We don't need to instance our kind of snow rock geometry. So let's select all of those and hit delete to get rid of them. And we also don't want this translucent material on our lights, do we? We want an emissive material. So let's go to our material manager. We'll go to our arrow here to go to Cycles 4D, Surface, and we want an emission material. We're going to put that, let's drag it on top of that translucent, which will replace it. And if we let's just start rendering this. So let's go to INSYDIUM, Cycles 4D, Real-Time Preview, stick it up there. So there are our lights. Let's go to our instance tag, and we don't need this much size variation, just a little bit of variation. Maybe make them a bit bigger. Okay. And in our, let's double click our emission material. And again, this is a one node material at the moment. So again, it's going into the surface of our object here in the output. We've got our emission. Let's change the color to an orange color. And we'll probably want to increase the strength of that a little. So let's get the strength slider up, make it glow. There's it glowing. So then let's activate our snow emitter, and then we'll have to obviously simulate this through. But there we can see, look, we're getting lights and we're getting snow in our scene. Let's come forward to maybe, we'll keep it going until we've got a decent amount of particles in our scene, something like that. All right. So this is starting to look pretty decent. Let's just increase the size that we're looking at in our real-time preview. I'm going to up my samples. At the moment, we're only sampling 10 samples, which means it's a little bit noisy. So we'll put that up to 20. All right, so we're getting this basic effect, which is looking good. Now, arguably, I'd say we can obviously fiddle around with these somewhat, but arguably those lights are still a little bit big, so I could put this down to maybe 10 to make them much smaller and more subtle. We could go to our emission and put that up a little bit to make them brighter, which will further illuminate the snow. Okay, and then from this view, let's just try going to our emitter snow tag and making the size multiplier. Let's make them bigger. Just makes that snow a bit more prominent. We wouldn't do this in the final render, but let's just make it a bit more prominent in our scene. Maybe that's a bit too much. Down to 15%. Okay. So there we go. That's not a bad look for our first kind of wispy snow simulation. So what we'll do is we'll close this down and let's just set this up to cache, so we have all of this data saved, and then we can do test renders should you wish. So let's just close down our material manager, and what we want to do is cache these existing particles. So we'll go down to our utilities folder in our XP system, and we'll choose a utility. We're going to choose a cache object. Now the cache, instead of the particles having to simulate every frame, it's going to save all of that particle data per frame. And there's two different options. You can either, the default, save it to external files. So you select a folder and every frame will render a cache file with all the particle data, or you can render it internally to memory, which will save it within your Cinema 4D scene file. And so for most purposes, I would always argue that saving to external files is the best option. So I'm going to leave it like that. I'm going to save my default folder as just my documents one, but I would urge you to create a specific cache folder in your kind of project structure, and you can select the folder location here. So let's leave everything else on default. I'm going to hit build cache, and you can see that it's going through our simulation, caching all those particles. So I'll pause this here, come back to you when it's finished. Should be a minute or two, and we'll see how long it took. Okay, and that cache is done. It took 1 minute 17 seconds for all 1000 frames. And now look, we can scrub through this simulation. See how, look, our two emitters have got a red cache tag on, so they've got data, and we can scrub through, which is really handy. Excellent. So now that is done, we could start looking at spitting out a test render. So let's go to our Cycles 4D real-time preview, just to make sure that we're happy with how this is looking. Now, one thing that we haven't done just yet, first of all, I think we made adjustments to the size of our snow, making it larger. And the more I look at it, the more I think that that was an error. I think this could be smaller. So let's go to our emitter snow instance tag, and then look, let's put our size multiplier back down to 10. Yeah, that's looking more wispy. I'm much happier with that. Now also, we could perhaps, let's just go to our, just close this system down, go to my blue softbox, and let's just see if increasing this is just going to brighten those up a bit. Yeah, that's looking better, something like that. Okay. That's looking good. And so obviously this is just a test render, so we're going to pick a frame where we're going to start this. So maybe frame 245, and then we'll just do, I don't know, a couple hundred frames, something like that. And if we just let this sample through to our 20 samples, and obviously, I mean, the camera's quite far back here, so those samples are going to be fine. So let's just close that down. Let's just come in a bit closer to our tree, something like this, something like that. Okay, and we can set up a render. So let's go to our render settings. We'll go to the edit render settings. Here we go. So these are all in default. Let's change the renderer to Cycles 4D. Let's go to the Cycles 4D settings. I'm going to make sure that my device is set to optics. If you have an optics enabled card, it'll be much faster to render in most instances. So pick optics. Very good. We'll come down and we're going to look at now by default, everything we're going to leave default apart from we're going to change the samples. Now remember, in the real-time preview we changed this to 20, which looked good. So we could just put 20 here, so it would mean that it's going to apply 20 samples to absolutely everything that it's rendered. But actually what we can do is use this really cool smart adaptive sampling. And if we click this, we can put the maximum samples that we want to get to, so we know that's 20. But then we can put a minimum amount of samples. So for the areas that don't require many samples at all, so let's put something like just 6 for that. And then we have this adaptive noise threshold, which is the threshold which kind of decides at what point it should use more samples. So let's put this on 0.05. The smaller the number, the more likely it is to use more samples. The larger the number, the more likely it is to use closer to your minimum. So that's fine. Then let's go to our output and we'll do 720p. That's fine. In fact, look, we don't need to. Let's just do a square aspect ratio because we don't need to render all of that black. So something like that, just reposition it. Okay, so we'll do 720 by 720, and we wanted to do frame 250 up to frame 500. That's going to be fine. Now let's go to, I'm not going to bother saving this, I'm just going to render it to the picture viewer. So let's just click off save. You can save yours obviously if you like, and that'll do for that. So let's close that down. Okay, so let's go to render to picture viewer. Yes, I'm happy to continue without saving. So now we're rendering to the picture viewer. All right. This is going to give us an idea of our particle animation. Now, of course, we'd make adjustments to the materials. We'd obviously hide this light, which is viewable in our test render. But this is just a test to get an idea for how the motion is looking in our scene and how things are being illuminated. So I'll let this chug through. You can see it's rendering, looking under a second a frame. When it's finished, we'll come back and we'll have a look and we'll see how long it took. And that's finished rendering now, and it took 3 minutes and 56 seconds. So let's have a look at our animation. So this, remember, is the first layer of particle effects to build up our particle Christmas tree. And this is working brilliantly. Look at this. We have got our particles kind of swooshing around with the turbulence, giving us that nice detail, but the flow field is maintaining that upwards spiraling movement. Remember, we controlled all of that and kind of damped it down by limiting the speed. And our instanced snow geometry is working really well with that nice translucent material, and it's being kind of illuminated and helping those lights, and we've got that kind of glowing look as they work their way up. So that is working fantastically, and that is the end of this first technique video to create our Christmas tree.